SNS College of Technology. In the lecture series, we have discussed about the first law of thermodynamics. We have discussed about the second law of thermodynamics. So, what is the need for second law? So, what is the difference between the first law and second law? So, today we are going to discuss about the what are the statements in the second law of thermodynamics. There are two statements available in the second law of thermodynamics. The first one is Kelvin-Planck statement. Okay. So, what is meant by Kelvin-Planck statement? Okay. So, here to understand this Kelvin-Planck statement, let us have a small example. So, let us have a system. Okay. So, consider this is an system. Okay. So, here we are supplying some heat. We are supplying some heat to this system. So, what happens is this heat, separate heat is converted into work. So, the separate heat is converted into work. So, this is condition 1. Next, let us have another condition, second condition. Okay. So, there is a system, same system. Okay. So, this is a system. We are supplying some heat energy to this system. Okay. So, here what happens is some amount of heat is lost to the environment. So, remaining is converted into work. So, these two are the conditions. Okay. So, now what Kelvin-Planck statement says is that here, so the supplied amount of heat energy cannot be converted 100% into work. So, 100% conversion of heat into work is not possible. So, some amount of partial amount of heat is converted into work and some amount of heat is lost to the environment. So, this is the Kelvin-Planck statement. So, no system can achieve 100% efficiency. So, here now let us have a small decision on this. Okay. Now, let us have a discussion that 70 kilojoules of heat is supplied. Okay, let us have a small example. 70 kilojoules of heat is supplied to a system. Okay, here 20 kilojoules is lost. It can be based on the first law of thermodynamics. We have discussed that some energy is used for internal energy. See, in such a way that 20 kilojoules of heat is lost. So, here 50 kilojoules only heat is converted for work. So, this is for the second condition. Now, let us discuss with the same thing here. Same 70 kilojoules of heat is supplied, but here there is no heat lost. So, here 70 kilojoules of heat is converted into work. Now, let us compare the efficiency of the condition 1 and condition 2. Okay. So, what is the common formula for efficiency is output by input. So, this is the common formula which we are using is output by input. Here output is work done and input is heat supplied. So, these are the two conditions, work done and heat supplied. So, here let us have the first condition. So, here work done is 70 kilojoules. Okay, work done is 70 kilojoules, whereas heat supplied is 70 kilojoules. Okay. So, as your efficiency we can multiply by 100. Okay. So, when it gets cancelled here, 100% efficiency. Okay. Coming to our second condition here, let us work out the same thing, the same formula, output by input. Here work done. So what is the work done here is 50 kilojoules. What is the work done is 50 kilojoules. Now this is for case 2 or condition 2. The work done is 50 kilojoules, and whereas heat supplied is 70 kilojoules. Okay, heat supplied is 70 kilojoules into 100. Okay. So when we have a small calculation here, 500 divided by 70. So here we are approximately getting 71%. Okay. So here in the second case we are getting 71%. So here 100% is not possible. So this condition is not possible because no system can give 100% efficiency. Okay. Whereas in condition 2, this is possible. Okay. So this is our Kelvin plan statement. So from this, what we conclude is that no system can produce 100% efficiency. Thank you.